Hi, I am Pelikan from Linköping University in Sweden, and together with my colleague Emily Hofstetter, I've looked at how robots can manage delay. Delay has been a challenge for human-computer interaction since the very earliest devices. Already in the 1960s, system engineers had trouble managing how users responded to very long delays. As Miller put it, if you address another human being, you expect some communicative response within X seconds, perhaps 2 to 4 seconds. Even though his response may not have the message context you want, you expect him to respond within that time in some fashion, if by no more than a clearing of the throat or a grunt. In conversation of any kind between humans, silences of more than 4 seconds become embarrassing because they imply a breaking of the thread of communication. This is similar to a phone line going dead. While computers are much faster nowadays, delays in the form of networking delays or intense processing time are still recurring problems. A range of design heuristics and solutions have been found for graphical user interfaces, and a wide range of progress indicators or loading screens have been designed. In interfaces that rely on turn-taking, some delay is actually necessary to mark the distinction between request and response. So a robot or voice interface cannot speak at the same time as the user is talking, for instance, and the specific timing therefore is different than for graphical user interfaces. At the same time, lags can be very problematic for such conversational dynamics. In human interaction, silence is not neutral. Extended delays between, for instance, a question and a response imply all kinds of social problems, from disagreement to inability to hear or understand, to complex relational concerns. In her work on interaction with Xerox copying machines in the 1980s, Lucy Suchman has demonstrated that this also holds for machines. If no action is forthcoming, humans will assume that the machine is broken. However, Xerox machines and computers usually have graphical user interfaces that can display progress bars or hourglasses to indicate that they are not broken during a delay. Robots often lack such graphical user interfaces. So in this paper, we are exploring how robots can use sound and embodied resources for making delays transparent. This question is actually still largely unexplored, although Japanese researchers have suggested that the token eto in Japanese, in English, could indicate, for instance, that a response is delayed. In our work, we looked at the Cozmo robot deployed in family homes, and we studied how the robot's existing design works to manage delay. We take an ethnomethodological and conversation analytic approach, and we video recorded the interactions, and then we carefully transcribed them to be able to understand how actions evolve on a millisecond level. We then also compared this to human practices for dealing with delayed actions on the phone and in co-presence. We looked at this specific face recognition sequence in which Cozmo is taking pictures and then learning a person's facial features. So it takes quite a long time, and Cozmo plays the following display. The sequence can take even longer with children moving around in bad lighting conditions. So this is how it typically looks in family setting.
Hey.
Hey. In the clip, the boy is sitting still during some parts, but then he's hitting his sister during another bit. Why does he time his actions in this specific way? Is this normal? Is this what people usually do? How would humans manage a delay coming from another human? Let's ask the expert, my co-author Emily.
Humans also have to deal with delays, and they manage them with their body and their voice. They may turn away or visibly do something to show that they're not available. Perhaps they're calculating, or they might do thinking while preparing to do something else. In a board game, for instance, if they're planning their next move, they might hover their hand over the board to indicate that while they know it's their turn, they're not able to do their turn and complete the move just yet. On a phone, they might hum or talk while searching for a pen to indicate that the phone hasn't gone dead and they haven't disappeared.
So let's go back and see whether these insights can help us to understand how people interpret what Cozmo does. We can see that, like humans who use their voice, Cozmo plays sounds which indicate that the robot hasn't suddenly broken, but it is engaged in a task. But then it's also so that most of the family members actively support the robot in this task by keeping still, until the robot plays the ding sound. This is when the boy recognizes an opportunity to move and to retaliate against his sister. So to summarize, our work contributes observations of how robots manage delay and the consequences of several design choices for users. First, we highlight that it is important that delay is managed in some way. For example, during a short moment where the robot then falls silent again, we observed that people got confused. We have then shown how the robot can successfully manage a longer delay through sound, but in the specific case here, the sounds indicate that humans can disengage, and some of them actually turn away from the robot, which is quite problematic for the face scanning activity. So in the paper, we highlight that designers need to consider carefully what responses the delay management displays encourage, and whether these are appropriate and aligned with the activity. Finally, our paper highlights that delay should be actively exited, which re-engages waiting users. In the case of Cozmo, the ding suggests that the activity is finished, and then a later draws people's gaze in anticipation that the robot is going to say something. In the paper, we show that, like in graphical user interfaces, delays that cannot be avoided can be actively managed. Robots can use sounds, movements, and facial expressions to do this. I'm really looking forward to meet and discuss more at the conference, or to chat more via email or social media.